Hello everyone and welcome to my channel. I'm Paolo, also known as Genoma on Instagram. Today I want to walk you through different approach to instancing. As you can see here, we're basically, instead of using the geometry itself to instance particles, we're going to instead use world space position texture that we're exporting from a very simple rendering setup that you can see here. We're exporting world space position and the normal information and manipulate those textures to basically recreate the geometry using instances, and also building a sort of flow field along the surface of the geometry. There are some side effects that I think are pretty cool when working with this approach to instancing, and one is that it takes some time to for the particle system to update, because we're using basically a lifecycle system where the particle ages and dies and is reborn in its original location. So I think that could be actually quite interesting to explore and creates pretty cool effects. One other thing that I've noticed is that basically, because the instances that we are creating are based on how many pixels are actually covering the image or the texture, the closer you get, the more resolution that particular area of the geometry gets, and so you're gonna have more particles, and your point cloud will increase in resolution in a way. And the further away you go, the least particle you will be creating, because there are more alpha pixels that are not carrying any information. And I think that is also pretty cool. So without further ado, let's delete everything and start from scratch. So the first thing I want to do is I'm gonna import an asset that I found for free on TurboSquid, I believe, but you can use any 3D geometry that is supported in Touchdesigner. You can also use one of the SOPs that are available here, torus or sphere or cube, whatever you want. I'm gonna add a transform just to allow me to change the position of that geometry later on if I want to, and a null, and then add that geometry into, or connect that SOP to a geometry comp. Again, this is the simplest possible render setup. I'm gonna add a camera, and I'm gonna add a material. Now the material need to be either Phong or the PBR material. In this case I'm using Phong. And it's not very important because we are not using the shading. And I'll show you later why. And then let's just add the render, and then we need to do some setting up of this as well. So first of all, I'm just going to set it to square texture, and the resolution of it depends on your computer, but I will keep it at 520 by 512 by 512. In the material, I want to go into the advanced tab, and as you can see here, we are this is where we are exporting. Basically, what are we exporting with this material? Which buffers? And by default it's set to full shading, but we don't really need that. So I'm going to export, instead of full shading, I'm going to export world space position, and I'm going to add a new color buffer and export the world space normals. I believe that's all for the material, and now let's go back to the render, and here we have quite some settings to change. So first of all, we want to make sure that we want to make sure that we're rendering only the geo one. We are gonna ignore the light, and then in the advanced tab we want to deactivate dether, and also set the number of buffer to 2 because of what we just did in the material. Let me check, but I don't think we need to add anything more. And now we want to take out the normals. As you can see here, we are immediately rendering out the world space position. That's going to be the location in space of our particles. Oh, one last thing that I forgot. Let's also set anti-alias to off. Good. Now we are taking render select, dragging our render onto it, and then selecting the second index there, index 1. And here we go, we get our space normal. Let me make sure, yes, space normal, perfect. Good. Then let's just immediately go and set up the second render, which is to show basically the particles, and I'm going to call this position. And here again, you should be free to do whatever you prefer or what you're used to. I'm just going to create a box, add a transform, scale it down to 0.1. Let's start like that. Add a null, and bring that into a geocomp. In this case, we're going to use the same camera, so I'm not going to add a new camera. That again can also be something that you instead add because you want to maybe look at the particle system from a different perspective. But for now, I'm just going to add a light and the render. And here as well, we need to do some changes. So we want to look at the Geo2. So we're going to only render out the particle system here. We want to look at the lights, and we want to keep the first camera. Now I'm gonna activate instancing and drag my position into the default socket there. Use that information, basically R, G, and B, to generate the point cloud or the particle system. Of course, I forgot to enable 32 RGB, so that is actually what we need to do. In that way, we can create instances even below 0 and negative space. Good. I'm then going to move away a little bit, kind of frame this geometry a little better. And here I'm gonna set this render also to be squared. 32, no, we can leave it 8B, sorry. Squared render, and then I'm just gonna add an out. Also a transform here. Set this to 1, turn the composition over, and then I'm gonna just visualize this. Now, the light is the most boring light in the world, so let's set that up a little bit. So I'm gonna just change the location of the light. I'm gonna activate shadows, soft map shadow, and then I'm gonna multiply this number by 3. The higher the resolution, the higher the quality of the shadows. And now we're starting to get something. And as you can see, we have basically recreated the geometry by just using particles in space. And if we are moving the camera, then we're just going to look at it from a different point of view. That's perfect. That's it. Let's move into the interesting stuff then. Okay, so why do we export the normals? The normal information defines the inclination, basically the angle at which each face of the geometry is at. So it has a perpendicular, is representing a perpendicular vector from that surface, which means that if we use, and I'm gonna set up a very simple feedback here just to show you. I'm gonna create a composite here, add a composite, set it to add. Basically what we want to do is create a feedback loop where I'm modifying the position. Feed back into that, add a map here. This is because the normals, I'm not 100% sure if they're normalized. I guess it's probably a vector, unit vector. So that would be too much for us to modify our position. So I want to scale that down here, multiply by 0.1. Let's make it very tiny. You can't see anything, but there is still something there. And yeah, then I'm just gonna drag this in, and as you can see, here we go. We are now moving the particles that have been generated for each position along their normals, the normal relative to that position, and that is because we are rendering the same from the same camera, means that each pixel representing a normal is mapped onto its own position. And when we modify the position, we can read the normal position from there. Okay, if I set this to minus, you will see them coming back in a little bit. So again, it's a directional vector that is pointing straight up from the face of the geometry. Let's just wait for them to come back. Here we go. Yeah, so, and you will see that the image will, or the structure, the geometry or the 3D model will be recreated in a way and then kind of collapse. Anyways, that's good. I'm gonna just remove this, and you saw how they shoot out the moment I fed directly the normal into it. But anyways, we want to find a way to have a way to reset our feedback. So I'm just gonna quickly create some variables, or one variable for now, reset, renaming it. I'm gonna add a merge because later I will, what did I type? Merge. And then I export a null, call it variables, and set this to view. And just link it to the feedback. So we're back on track. Good. So what do we need to do now? I have here a screenshot that represents what we need to create now. And if you remember, I was talking about this flow field created along the surface of the model. So this is the setup that allows us to do that. And basically what we're creating here is something called tangential displacement, or we're basically modifying and manipulating the normal information in such a way that instead of having a vector pointing straight up, we have a vector that follows the surface of the geometry. I think it's nothing more than a dot product, but because we have the noise here, there's something extra. So let's start. We want to create noise values basically based on the current position of the particle. That's very important. We're gonna then multiply that by the normals, and then combine the channels, add all the channels of those pixels, and that is the dot product basically. I did it in this example, as you can see here, it's done with the GLSL, but then I found out that you can actually do it easily with the math. So with the math top, so we're gonna use that, and finally multiply again the normals by this value, and that one gives us the alignment component, and finally subtract the noise vector or the noise information from the alignment component. And finally, we're just going to multiply that again to keep it under control with a math. Quite straightforward. So let's try and do it. From here, I want to create a noise and set this to noise only. I want it colored. Very important. Bring this to 0 so that we have a value that goes above and below 0. I also want to bring the current position, which is the beginning of the feedback here, into it, so that the noise is generated based on 3D information. We can play around with this value later. I'm going to set this to 3 for now. And then, as we said, we want to multiply this by the normals. And then, using a math, we can select this 3 channel, deselect alpha, and set combine channels to add. What this gives us is scalar value, so all the pixels are the same value, and it's just a value between 0 and 1. And then we take that and we multiply it by the normals. Am I correct? Yes, so we are here. Multiply that by times the normals. Then we're gonna use a composite to subtract the noise from that. And again, very important to then set this to subtract. So this then is to go into our math and multiply that by some number. Let's start from maybe 0.1. Okay. And now if we add this to the composite over here, then we start to have something. Now, this is not necessarily what we want. The particles, after a short while, they will just start to go in a very randomic, or not quite randomic, but they are just not able to stick basically to the surface, and they take off with the noise values and so on. So again, but we're getting there. What do we need to do is to find a way to reset the particle position. And you might have seen this in many videos. We basically need to create something that represents the life cycle of the particle. I will start by, again, from the main render, take out noise, set this also to noise output, and then here set it to random. This basically generates for each pixel in the texture a random value between 0 and 1. That's going to be the starting age of our particle. And then we need to create a feedback that will increase that value. So I will add a feedback. You can just use an add. We're basically, with this, we're adding, how fast is the particle aging. And then we want to add a limit. And that is going to say basically how old is the particle able to age to. And we want to set this to 0 and 1, meaning that the living time maximum should be set to loop, and basically means that when the value reaches above 1, it's looped back to 0. I don't think it makes a big difference. I tend to also activate normalize here. But it's not going to make a big difference. From the noise here, or literally from wherever you want really, as long as we have the same size, I'm going to take a constant and set this, very important, to set resolution only. Now, this basically is a clean texture with each pixel set to 1, and that is going to be our speed, how fast is the particle aging. And for that, to set that value correctly, we want to create a couple of constants, or numbers. I'm just gonna add a constant here and say, call the first one lifespan. And this is basically how many seconds do we want our particle to live. I'm gonna set this to 2 for now. Then this one is gonna be called age speed. You can call it however you want. I'm gonna copy this parameter here so that we can keep it dynamic, so that if I change this to a longer life, then it will be automatically updated. And then what do I want to do? Well, I want to calculate how much do I need to increase the value for it to take 2 seconds to go from 0 to 1. And to do that, I want to divide 1 by how many seconds, which is the previous value that we created, times the frames of our sort of simulation. So, and I know that I'm going at 60 frames per second. So we're gonna get a very small value here, and we have it also here. So I'm just gonna merge it in so I can now use it. And selecting our constant, we can set this to be the value that we are adding. And finally, so I'm gonna move this add down here. We're increasing here, so we're taking the noise, we are adding this value, we are limiting it if it is going above 1. I'm gonna bring the limit back into the feedback, and then if we look at this texture and set to nearest pixel, you can see how we are going up to a white if you look at this pixel, and then when it gets white it goes back to black and starts over. So that is our life. Okay, I'm gonna move things a little bit down here, but that's not all, right? How do we use this to reset the particles? Well, we can take a multiply. Basically, we want to, oh no, sorry, I forgot. First, we want to use a threshold, and then we want to basically detect when is the particle being reset to 0. The value you want to look at is actually the age speed, and I'm afraid that if I would explain it, it would take me too long. But because we don't have clear steps, when the value goes over 1, it wraps around, and then that means that it's never going to be exactly 0. It's going to be a little bit of 0, but a little bit above 0, but it will never be above the age speed, basically. So if you use that and we set this to greater, then we can see that basically we have this sparse white cloud where every pixel that is white, it stays white for 1 frame, and that represents a pixel that has just been recreated or a particle that has died and reborn. So we want to use that information using a multiply to take the original position. Take the original position multiplied by this information here, and as you can see, we are highlighting the position where the particle should be reset to. And how do we reset it? We just use an over, we just add that pixel over the current position. And here we are. I can now see there is some issue. There are many issues, but there are some issues here because we are using a light down here. Let me just reset it here. Okay. So if I select this light and we look at shadow caster, we are casting shadow also from the other geometry in Geo 1. So I want to write just Geo 2 here. So now you can see that there are no dark spots anymore. That's good. So now we are resetting our particles. I think they're going a little bit too fast. So I might multiply this by 0.01. Okay. Not quite there yet. But as you can see, basically the particles are being generated, and then they die and they come back to where they started from. I'm gonna lower this down to 1. Now we are slowly starting to rebuild that information, the geometry again. Maybe the light is on the wrong side, so let me just move it on this side so we have a little better. Yes, there we go. Okay, one thing that then we want to do, there are 2 more things I would like to do. One is give some directionality, show where these particles are going, not only by the movement, but their orientation. So I will start by increasing the length of this particle on the z-axis to 5. Now you can see they're little sticks. And then, because this is the directional information that they are feeding into the position, and we are modifying the position with that, basically I get direction for free. So I can take out a null, rename it direction. I am not able to spell direction. Good. And then wait. select my Geo2, go into the second tab of the instances, and then apply this or put this into the rotate to operator. Here I will feed the information, R, G, and B, and we are starting to get somewhere. You can see that the flow is actually going along the surface. There is still some problem with the resolution maybe, or how close to it is, and that's a lot based on what parameters you're using and whatnot. But yeah, so the next thing that I was mentioning is that we want to make this particle maybe be a bit more elegant in the way they are born and they are going to die. And we have this information here, right? So this value goes from 0 to 1. We could use this value basically to scale the particles up and down. So I want to take a lookup table, or a lookup top, sorry. We're going to set this to chop values, and then we're going to create the curve that we need to use, basically, using a pattern. So what am I trying to do? This value goes from 0 to 1, and then it goes back to 0 all of a sudden. And that creates this very jittery effect where the particle just all of a sudden disappears somewhere and then it appears somewhere else. So to fix that, I want to create or to map that value instead of 0 to 1, 0 to 1 to 0. And I can do that by using a pattern chop. And as you can see, it's basically representing a value that oscillates. We want to modify this so that it looks like the one we want. You can just change this value. So I'm going to move it up 0.5. Now the value goes from 1.5 to minus 0.5. I'm going to set the amplitude to 0.5. Again, now we have it 0 to 1. That's good. But it starts at 0.5 and ends at 0.5. That's easy to fix. We just take the phase and move it. 0.25. And now you can see we have a clean value that starts at 0, goes up to 1, and goes back to 0. I can drag this here, and in the chop field. And now if we take a look at this, and I'll set it to nearest pixel so we can see the actual pixel. If you look at one pixel, it's just gonna go up and down, up and down, up and down. So it's oscillating, it's not jumping anymore. Okay, I can take this out now as a null, rename it scale, and then use it, use it in the first tab, set it to scale, and then R, G. Oh, sorry. Let's use R. Doesn't really make a difference, but it's clear. And then, as you can see now, if I look at this very closely, you can see the particles just popping in and out of existence following the field that we created. And this helps also to keep the geometry a bit more controlled. Okay, I can see my frame rate is a bit low, and it shouldn't be that low. I don't have the strongest of the computers, and why is that? If you look here, all this stuff is purple. And we don't really need that. Means that we are actually instancing particles for every pixel in the image, but what we really care about is actually just this bit. So we need to clean this up a bit. And to do that, we can just take a threshold from the main render. Threshold, I'll bring it over here from the main render. And then I'll set this to nearest pixel so we can see what we're doing. I'll change this to alpha. And basically now we are able to just say, okay, what of my, if you look at this texture, there is some alpha information there, but this is always opaque. So basically we're saying where the alpha is less than or more than, yeah, when it's more than 0, do it white, and then we have a threshold. At some point we just want to make sure that the alpha is 1, or just, doesn't really matter. The point is we can use this then to again multiply and clean up in this way this information here, and all of a sudden we have back only our nice pixel. I'll just set this for nearest pixel just to make it very clear, and then feed this instead. And now you can see I've improved a little bit my performance just by doing that, which is pretty strange to me, honestly, because one thing we need to do is to actually go in here and set active to the alpha channel. So by doing that, we are just saying look at only particles or only pixels that have I believe 1 of alpha, so they don't have alpha less than 1. I'm not sure if it just needs to have any sort of value that is not 1. I'm not sure, but as you can see now we're back at 60 frames per second. We have gained back all the performance that we need to even scale this up more. Yes. Yeah, we're basically done. You can see now if I zoom closer, I get more of the details out in a way. We have this effect that kind of takes a while for the particles to regenerate, like quite a magical behavior in a way. And then you can play around with all the different parameters, right? So yeah, you can reset it. We can set the noise value to be lower, and then you can see how the geometry really comes out, and it's beautiful. And then you can increase it, kind of dissolves a bit. Yeah. What else? We can manipulate this speed to make it go crazy backwards. Yeah, because the good thing of this is that technically if I put it to -1, then yeah, you can just invert the direction, which is pretty cool. And I think that's it. One last thing, you can just, as I mentioned earlier, just bring in a torus or whatever you want, put it in, and you're good to go. It's basically adapting to anything you're adding, and I think it's just a very fun little setup to create some pretty cool effects. And I hope you enjoyed this tutorial. Of course, as they usually say, like and subscribe. I would really appreciate that. I'm trying to, of course, put out more content, and also feel free to suggest things I should look into, or if you want to see anything, if you have questions regarding this, I would be glad to answer you. So thank you very much. I hope you enjoyed the tutorial, and see you next time. Bye.